Alright, so before I start this video, which is a part 24, this probably, to be honest with you guys, there was a snow yesterday. We didn't have school yesterday. Ice Step was due on that date. I think today we might have Ice Step again. So, even though we didn't even take it. So hopefully Ice Step will be we were scheduled for iStep, and now I'm actually afraid that iStep is going to close this week. I don't know. I think today we might have school. I'm not sure it's going to be like a 2 hour delay or like or like a normal person or like a normal time. All right, so I gotta be honest about whenever you have when you're supposed to be in when you're my area is that I do not know if we're having school today because snow has been coming a lot this month, and I just wish spring would just come right now. Cannot wait for spring to come. Like I said, I know people are dying to wait for spring. Yeah, cannot wait for spring, obviously, guys. So yeah. All right, so let's get on with the Lewis dot. The Lewis dot. The ninth one is the Lewis dot. Lewis structures, also known as the Lewis dot diagrams, Lewis dot formulas, and Lewis dot structures, and electron dot structures. Lewis electron dot structures, LEDS, what this stands for, are diagrams that show the bonding between atoms of a molecule and alone pairs of electrons that may exist in the molecule. Okay, so I did this previously. Um, you move this around here. So I would just move this politely. All right. So this is what it looks like, and this is the CI or the CL, I should say. This is located to the bottom and located to many, which is located right here. And there's something that is missing, and that's because CL and C equals this part of this. So the periodic table of elements. I'm gonna show you what the real one is. So when I show you about my old papers, OH2. You guys know what it stands for, which is the lactose, the D-galactose, and the D-glucose. I'll show you the rest after I take care of some stuff. This is an ANA and a CL, which is 8 plus and an 8 minus and an 8 plus, which is on the H. 8 pluses are on the H. H's, there's an O, which is 8 negative, which is 8 minus, definitely. Negative contributes the O, definitely. So if you guys have any questions, just let me know. Why is it not exiting out? Wait, I'm not ready yet. Okay, just making sure. Metalloids, which is related to Metallica, my best friend. We're not talking about her right now. We're talking about the metalloids, sorry. The 10th one is metalloids. An element, e.g. germanium or silicon, whose properties and intermediate between those of metals and solid nonmetals. They are electrical semiconductors, which is located at the periodic table of the elements, which is can be explained. I'll show you the full definition. You guys can see what the page is actually like. So, because this is the metals and nonmetals can be both explained. I'll show you the rest when on screen. So yeah, this will be provided. Your teachers probably taught you this. Yeah, they did. All right, so the N is actually neutron. I learned about the neutron since 5th grade, and it was pretty exact awesome. Alright, so the neutron, the 11th one is neutron. Uh, the the a subatomic particle of the amount of the same mass as a proton, but without the electric charge, present in all atomic nuclei except those of ordinary hydrogen. Hydrogen, I should say. All right, so this is what it looks like. The carbon of six neutrons and the six protons and the six electrons, which can be explained at the end of the last video. So yeah, just look at those for like a few seconds or so. This is a neutron decay, which you can read. You can look it up if you want to. This is what it actually looks like. The neutron looks like, which is below to the carbon. This is what it looks like in the middle. This is also what it looks like for the carbon atom, which is the nucleus comes from, the pluses and the red spots, which is a proton and the neutron comes from, and the electron is the minus. That just relates to the neutral size. And a proton comes with a neutron. They both are together. That's where people are playing together. Just they both combine together. This is what it looks like in the first row, which can be explained after this. Can be explained with the protons, a lot of protons, and there's 8 protons and there's 1 neutron. That is in the middle, which can be kind of a thing that can be described. Yeah, your teacher probably taught you all of this in high school. Yeah, Mr. Murphy taught me a lot of things. Taught us a lot of things actually. All right, finally I can actually get out of this. My thing wasn't working for some reason, so yeah. It's actually the nuclei except those of ordinary hydrogen. Can't be one of those of ordinary hydrogen. It doesn't really fit in a neutron. Which is other nonmetals. Other nonmetals, I should say, is actually the 12th one. One is other nonmetals. 17 elements are generally classified as nonmetals. Most are gases: hydrogen, helium, and nitrogen, or oxygen, fluorine, neon, chlorine, argon, krypton, xenon, and radon. One is a liquid, bromine, and a few are solids: carbon, phosphorus, sulfur, and selenium, and iodine, which can be all over of the alkaline earth metals, which is Be, Mg, Ca, Sr, Ba, Ra, and alkaline earth. This is where it translates to. This line is the first one, can be explained in the back. Back to the right is actually all the yellow ones, or orange, or yellow, okay? The other nonmetals explained by H, C, N, O, P, S, S, E. And the reds are actually made by, which looks like the nonmetals, can be explained, all of this. Li, Na, alkali metal, and which is a K, Rb, Cs, Fr. Here's are the greens: actylate, which is the greens, provided by AC, sorry, TH, PAU, MP, PU, AM, CM, BK, CF, ES, FM, MD, NO, LR. Which can be explained a lot of things. I'll show you them after I'll show you the paper about what I wrote in Mr. Murphy's. I took a long time doing it. Actually relates to other, can be explained, all this. After the other video I'm going to do is I'm going to show you some more assignments on real life paper that I actually wrote. Alright, physical change is actually related to the boiling water, but it's this physical change is actually more different, which can be explained by after I talk about this part. Excuse me, guys. All right. I'm not having a cough attack or anything. All right, physical change. The 13th one is physical change. Physical changes are affecting the form of a chemical substance, but not its chemical composition. Physical changes are used to separate mixtures into their component compounds, but cannot usually be used to separate compounds into chemical elements or simpler compounds. All right, so physical change, which is a physical change, is actually when people are when hitting or kicking or violation or hitting is actually the physical change. When a person is actually the movement of physical change, which can be explained in or written. When somebody hits a person, it's automatically the movement of a physical movement, which can be put down to a different level. So, yeah. All right, different stages of matter. Physical change, which is the water, which is normal. Water vapor, which is a hot. Ice is actually cold. Solid, liquid, and gas. Solid is one is melting, and liquid is actually bubbling, and gas is actually the fart, or actually something that someone farted, or something smells good, or something like that. Could be it. All right, physical changes in matter. All right, butter, in the butter of melting, there's ice. Ice is actually melting. Chemical changes in matter. The nail does something to that nail. Nail changes the atmosphere. In the dough, which is a baking bread, it automatically cooks right away when it provides in the oven. Can be explained. All right, so here's the other part, but I don't bother seeing. Organic is actually one of those four things, and inorganic is actually one of those four things, which is I cannot see what has actually been. I cannot see back there. I cannot read this because all the words are actually. There's some words I can actually read, some I can't. All right, so opponent is actually inorganic, and this and I don't know what it says. Let me know. And the carbon dioxide, and I don't know what the unit cells. And then organic is actually looking like the. No, I wasn't ready. Darn. There's no such thing as Q. All right, so there's a railroad, and there's a salty sugar, and there's methods, and there's I don't know. I cannot read this tiny. I cannot. Does anyone knows? Does anyone know how to? Does anybody know what this is? Just what is this? And what is this? What are those things? Just tell me what they are. Just tell me what they are, and it starts. I'll give you a hint. These pictures can include all of those things. What do you think there is? Because I cannot read that well. Cannot read very far back. All the words are actually small. Sorry about that. All right, physical change, which can be explained by this one. This one, it can be the hammer. Physical changes might be caused by grinding, cutting, crushing, bending, breaking, heating, and cooling, changes in phase, and squishing. All right. All right, radiation. I'll give you a few minutes. Alright, the 14th one is radiation. The emission of energy as electromagnetic waves or as moving subatomic particles, especially high-energy particles that cause ionization. Divergence out of a central point in particular evolution for an ancestral animal or plant group into a variety of new forms. That looks like reminds me of a sign, but it's actually the danger of radiation. So don't actually do not do anything bad or something like that. I don't know what it does, but just what do you think it does? Just give me your best answer and I'll approve it. This goes for all of you. What does danger radiation do? With your own words. What is danger radiation? Look up if you don't remember. That's what I meant. All right, solution. The 15th one is solution. A liquid mixture in which the minor component, the solute in parentheses, is uniformly distributed with a major component, the solvent, a means of solving a problem or dealing with a difficult situation. When you don't know math or science or social studies or English, if you don't know any of the like for math, for example, when I'm in algebra 2, when I don't know how to do something is actually kind of challenging for me, which is actually which is the light bulb that can give you an idea, can be actually the explain the social solution problem. If you're learning about the solution problems of math, is actually pretty hard. So which a teacher can actually write for you. A problem could be written by if you try to use your calculator to give yourself an answer and figure out what the number goes to. Just learn about that for a second. Think about it. Think about your mind. All right, I'll give you a few minutes. What does problem solution involve? Comment down below. All right, the 16th one is shielding effect. Repeat, shielding effect. Shielding effect. The shielding effect can be defined as a reduction in the effective nuclear charge on the electron cloud due to a difference in the attraction forces on the electrons in the atom. It is a special case of electric field screening, which is actually described by that I've actually learned since the first or second semester, which can be actually explained. I actually heard of this one before. I actually heard of a shielding effect since like in 5th grade. So yeah. All right, so this can be explained by the Frick GHZ in parentheses, which can be like provides by electromagnetic emission, which is by negative 110, negative 100, negative 90, and negative 80. Without shouting, and with shouting, the without shouting is actually the blue line, and with shouting is actually the red line. So it translates to 1.0 to 9.0, which translates to like about negative 105 or negative 108. What do you think it translates to? The inner pair effect is actually the Schrodinger effect. The strong S better than P, better than D, and better than C, which is the C can be repulsion or exotic, which can be pretty exotic of some point. All right, so penetration of n equals 3 orbitals into 1 8 region and 1s, electron probability, which is the AO and the 4AO, which is a free P and a free 6 and a free D on a black line, free S on the red line, and the free P, which is the dotted blue line. And the free D is actually the dotted line. One space and one dot can be explained. And an AO, and a 5 AO, and a 10 AO, which can be, and the free 8 is actually, I'm not sure what it says here, but it's actually the straight line. Like a worm that is curling on the top. Excuse me. Example of the shielding effect. The atom in the excited state with one electron in the 1s and the one electron in the 2p. So the proton is actually 2 points, and the neutron is actually both, which is actually the proton and the neutron stays the circle, the tiny one, and the electron is actually the negative, like I said. Or the He-ion in the excited state with one electron in the 2p. This is a helium. Sorry, the helium atom and the helium ion, which is only one proton. One electron and 2 protons, and neutron is 2, which can be explained by the helium, which is what helium comes from. Which can be, if you want to learn about more protons, like how many protons have they in this picture, they have 2. Sorry for my confusion. So yeah, factors affecting values of ionization energy, screening effect or shielding effect, combined effect of attractive and repulsive forces between electron and proton. 1 divided by number of inner cells, Na2 in 496, which is actually come by the effective or attractive and repulsive forces between electron and a proton. Ionization energy, which is A. No of inner cells, which is Li and 1. Ionization energy is Kj and mole, which is 520. Which is which it is expired by career launcher. All right, temperature. Excuse me. Temperature. The 17th one is temperature. Temperature defined. Temperature is a measure of how hot or cold something is. Excuse me. Sorry. A measure of average kinetic energy, which can be explained by the kinetic energy of the particles in the object, which is a type of energy associated with motion. The terms of hot and cold are not very scientific terms. If you feel cold, then you actually feel okay. When you feel like a headache, if you have like a headache, then you actually feel something cold when your head is starting to get even colder. Or if you gone into a swimming pool, if you're outside in the cold, that can proceed right there. Which the cold just runs lower. So when it's hot, if you're feeling sick, like the sun, then how hot the sun is like really, really hot. And when you're feeling sick, or if you're feeling sick, then you actually feel really sick about 100%. When you're not feeling good, when you have to stay in bed for a long time, when somebody has to give you food or soup. I'm okay with soup, but okay. This is what the sun of how hot it is looks like. The gas properties definitions, which is the Glenn Research Center, large scale of whole gas of micro, moderation, pressure, density, energy, temperature. This is the sticky and splingy, offusion, and what does this rest of this mean? Give me your best effort. Heat transfer, warmer object, and heat transfer to cooler object. And the cooler obviously runs down, and the warmer object runs up, like very up to this guy. All right, so what is temperature? This is the lesson of which is located at the 220 C. If you're at the negative, if you're at when it runs negative, it's really cold. You cannot even feel it. You'll freeze like an iceberg. There's so many ice bites that can kill you. So I was gonna sneeze, but last week temperature definition. Alright, temperature is a measure for homes and cloudiness and can be felt or measured with a thermometer. If you have a thermometer when you're feeling sick, then you obviously don't feel good. Temperature measures how fast the molecules in the material are moving. I actually learned this for the Houghton recently, back in when I was like 6. I realized how sick I was getting. I looked at the temperature in the thermometer, shows you how sick I am. If you're feeling like a 90%, then you obviously kind of feel sick. If you're feeling lower than those things, then you're okay. If you're feeling the middle, then you're feeling okay. When you're feeling cold, then you need something to fill you up, like a warm blanket, which can be pretty much explained. How many slides do we have? How many slides? All right, so there is no such thing as a U or W, X, Y, Z in this terminology. All right, so the valence electron. Repeat. Valence electron. The 18th one is valence electron. And I learned this for like back in 5th grade. In chemistry, a valence electron is an outer shell electron that is associated with an atom that can participate in the formation of a chemical bond if the outer shell is not closed in a single covalent bond. Both atoms in a bond contribute in one valence electron in order to form shared pair that I have actually seen before. This will take you familiar. You probably learned this for like 5th grade, something like that. You probably learned this for like middle school. All right, there's the nucleus in the middle. There's a sodium. There's the red point. The red dots are in the as soon as this goes away. This is the valence electrons that are between together. There is the even Na that can be explained in those videos. Okay, so they are 4 electrons, which is from hydrogen and from carbon, which is the H is for hydrogen and the C for carbon. So which can be explained. Okay, so the H through all 4 H's and 1 C can be like the right and the X. There's the O and 2 H's. And there's the other one, which is the second row, and there's the valence electron, which is the yellow dots. And the nucleus is in the middle, and the shells are in the blue lines. The blue circles right there. That's where I'm pointing. All right, so if you guys have any questions about the valence electron, just let me know. Or I'm gonna go over with the questions about the other slides too. That can actually help you more. All right, last one, vaporization, which can be the water vapor. The vaporization. Repeat. The vaporization. Vaporization. The last one is vaporization. Vaporization or vaporization of an element or compound is a phase transition from the liquid phase or to vapor. There are two types of vaporization: evaporation and boiling, which can be explained in other parts of that too. Evaporation is a surface phenomenon, whereas boiling is a bulk phenomenon. Alright, so let's start with a TC degree. H2O gas, which is H2O liquid, H2O solid. This is the gas of the lines. This is the liquid of the bubbles popping out. There's the solid where things starts to melt, like ice cream, ice, regular ice. Ice melts pretty quickly, so eat them very fast, and and like and when the heat starts to melt, um, when you feel like you're gonna melt with a hot day, for example, when your banana split starts to melt, that's what you're feeling hot for. There's a boiling of the liquid. This pot is out of liquid. There's a smell that is actually by gas. You can actually smell what it smells for. I actually learned to guess since I was 3 years old. This is translated to Spanish, so I'm not gonna read that. Measuring specific latent heat of vaporization. N, number turns, M equals 0.2 kg. Q equals NX 24,000, and I equals Q divided by M, which can be explained by this picture. What do you think they're doing? What do you think this is about? The this thing and the this thing. Let me know in your best effort. Alright, so this is the plasma, which is aerosolization and ionization, gas, the solution, condominium, and liquefaction, and vaporization, which is liquid. It's solidification and fusion, which is made by solid, and a fusion, which is made by liquid, which can be what is actually pointing. Sorry, I didn't mean to say that, but okay. All right, so vaporization, which is actually the first one is actually low, and the second is actually more and more vaporizations, and there's the third one is actually more vaporizations, which is the valence electrons. More electrons are coming this way. What do you think that says right there? All right, sorry. Evaporation and condensation. Individual molecules can change phase anytime. Evaporation, energy reached for overcome phase convection. Higher energy molecules near the surface can then escape. Condensation, gas molecules near the surface lose Ka to liquid molecules and emerge. This is what the water looks like with the straws looking. There's some, but what just comes from the evaporation looks like. This is all this looks like. That can actually be explained. When you put something in there, when you put something in the water like a fruit, I'm gonna pretend that I put a strawberry in the. I'm gonna pretend that I put an olive in the water, and it automatically sinks. So, or something that can float, like when it can float or sink, like in different ways. We actually learned this for like preschool. Actually, I actually like doing the float in the sink. All right, so plasma and the gas. I already explained the second one. So, what do you guys think that can actually be meant? What do you think that gas represents? And what do you think that plasma represents? What do you think liquid represents? And what do you think solid presents? All right, let me know in the comments, and I'll see you guys on part 25, which is going to be, I don't know how many slides I have got, but I'll let you know until the end of part 25 or so. All right, guys, all right, hopefully we have school today. Hopefully we do. I've been missing so much school, so, but hopefully school is actually today because I've been missing a lot. So hopefully I'll get my assignments turned in time because I'm actually pretty slow, but not all slow. I can actually get them done in time. So remember what I said in the vaporization. Remember all of this. Most of you guys have tests or something like that. All those above. So, all right, have a good day.